Hey guys, BuildZoid here, and today we're going to be taking a look at taming the 14900K on the MSI Z690-A DDR4 motherboard. Now, the BIOS I'm on is this version, which does have the OX129 microcode and the Intel default settings profile. Right, so we're going to start with just Intel default settings. So I've basically just cleared CMOS, right, and we're just gonna take a look at how that behaves. Which, if you've seen the previous video, you already know why I'm doing this, because, yeah, this motherboard has some kind of issue with its power delivery where, while Windows is starting up, it hits incredibly high peak voltages. The 129 microcode is supposed to prevent the CPU from sending vid requests for anything more than 1.55 volts, and it does do that. But for whatever reason, this motherboard, when, like, initializing Windows, just, like, manages to like overshoot that 1.55 volt limit. This isn't actually as bad as I've seen it get sometimes. So we're gonna do a quick restart. Because 1.56 volts is like that would, you know, I'd honestly consider that intolerance. But if you get unlucky enough, sometimes during startup, it hits 1.59 or even 1.6. And as far as I can tell, that seems to be some kind of bug with the voltage regulator. I kind of suspect it might be because the Intel default profile uses a really droopy LLC. And in my past experience with some MSI motherboards is that, like, on very high VDroop LLC settings, they have weird issues a lot of the time. Because, like, I think MSI actually, like, fine-tunes the voltage regulator for relatively shallow load lines. And then when you just slap a really deep one on it, it causes all kinds of weird issues. Though I've also seen some MSI motherboards that don't work when you remove all VDroop. So, quite frankly, like, I don't know what they're doing at MSI with their voltage regulator tuning. Because the number of times I've seen, like weird bugs on like MSI VRMs is just kind of typical. It usually happens at one of the extremes of the load line calibration settings or with the switching frequency settings, where, like, if you max out the switching frequency, things get weird. Or actually, I've seen weird things like this, changing the switching frequency, changing the average output voltage, which is not supposed to happen. But yeah, like, it doesn't happen like that. Anyway, we're not going to get into that, but yeah, I've also, like, so I kind of suspect that really high voltage spike when Windows is starting is some kind of issue with the voltage regulator's control loop on this motherboard. So it might be, like, this behavior might be present on some other boards. I'd imagine it's probably present on every MSI motherboard that uses this VRM, but there's a lot of MSI motherboards that don't use this VRM, as in they don't use this same voltage controller, and those probably don't do this. But anyway, so yeah, so that's like the kind of like first concerning thing with this motherboard. And I really think that's just like MSI has some kind of bug in their voltage controller configuration. Because it's not a vid request from the CPU. Now, once you're in Windows, the vid limit does its job, and as you can see, 1.54 volts. And the reason I'm running Cinebench 15 is that it just so happens to trigger the highest voltage spikes out of, like, the various applications I've tried. Even though it's like an all-core workload. And the reason it triggers them is, like, right as it finishes and right as it starts, it just really doesn't, like, the way Intel generates the vid requests just really doesn't mesh well with how Cinebench 15 starts and finishes. Which I would say is the thing is, like, Cinebench is Cinebench 15 is really, like, consistent about causing high voltages. But technically the same, like, the thing that, like, the reason Cinebench 15 sees these high voltages can occur in other software. It's just that Cinebench 15 triggers it very, very regularly. So I like using it for testing because it's very reliable at, like, causing this issue to show up, and I don't have to, like, you know, go through a bunch of other applications and load scenarios to trigger this kind of behavior. But yeah, so once we're in the OS, you can see that Cinebench 15, like the vid limit is enabled. It's just that during Windows startup, the motherboard has, like, there must be some kind of weird transient that happens where the motherboard freaks out and then it overshoots to 1.6 volts. Because that's what it looks like to me on the oscilloscope. And that would be totally in line with my past experiences of MSI voltage regulators. Now, actually, we don't need to run any more 15. The next thing I want to show is Cinebench R23. Which we're actually going to be using for our, like, performance testing here. And actually, while we're running R23, I should point out that the voltage sensor on this motherboard is not accurate. So this core voltage readout over here, as far as I can tell, if you're on the Intel default limits, it's off by about 30 millivolts. And the reason I say on the Intel default limits is because how inaccurate this voltage sensor is directly tied to how much current is flowing through the CPU socket. So like at idle, it's actually pretty accurate. At high current, it's more like it's progressively less and less accurate the more current is flowing in through the socket. And by less and less accurate, I mean it reads progressively higher voltages than it should. So yeah, but on Intel defaults, when running Cinebench R23, it's off by about 30 millivolts. We're not going to go into how to prove that right now. It's just a quirk of how the sensors are wired on most Intel motherboards, actually. Like, basically, the voltage readings from the, like, Nuvoton whatever chips are never accurate. Like, okay, that's not true. There are some motherboards that actually have, like, a pretty fancy workaround for this issue, but generally speaking, the voltage readouts from the Nuvoton chips aren't... You need to verify that they're actually accurate, and we're not gonna get into how to do that today. Anyway, so we're gonna run some Cinebench R23. And now what I want you to pay attention to is the score as well as the average voltage. So you can see our core voltage is about 1.25 volts. On the oscilloscope, it's about 1.28. So the CPU is actually getting about 1.22. Right now, because again, that sensor isn't super accurate. Anyway, and we get a score of about 38,000 points, which is actually really good for this CPU. On most other motherboards, it gets like 37,000 points. So yeah, I'm not sure, like, so it seems to be scoring about 500 points higher on this board than on some of the other boards that I've tested on the Intel default settings. I'm not entirely sure why that is. Could be a quirk of, like, the power monitoring being... Oh, that would actually make a lot of sense. Yeah, I wonder if the DC load line with the Intel default settings is set too high. Because that would do it. It's really, really hard to verify that, though, because we don't have an accurate voltage sensor. But anyway... So let's do something about our very high voltages here. Now, unfortunately, MSI, for reasons that I don't understand, decided that they're not going to have the VR voltage limit exposed in the BIOS. Because that's not like a feature that MSI has to go and implement. That, as far as I know, is a standard feature of Intel CPUs. And they're just not exposing it in the BIOS. So you can't set a voltage limit like you can on, say, Gigabyte and Asus motherboards, where you can just tell the CPU not to send vid requests greater than X, where X is whatever the hell you punch into the setting, right? Now Intel, with Intel default settings, right, Intel is imposing a limit of 1.55 volts, which I hope for Intel's sake is low enough. But if you're paranoid about the longevity of your CPU, if your motherboard has the VR voltage limit thing, you can just set a lower limit, right? Unless you have an MSI motherboard, because then you don't have that setting, so you can't do that. But anyway, so We can still do some things about the high voltages that we're getting on this board, though, and we can also slightly improve the performance. So the first thing we're going to do is we're going to set the load line calibration to mode 3. Now, this is lower than I would go with for, say, an Asus or a Gigabyte motherboard. That's mainly because on the Asus and Gigabyte boards, you can just set a voltage limit, whereas here you can't. So due to how Intel's V-droop compensation works, which is on the CPU, it's not on the motherboard. Like this is on the CPU side of things. We don't really want to be running a particularly high AC load line. And and my thought process on like maintaining the, like, being safe with the CPU is that if you use the Intel default settings, you want to stick to those, right? You want to have all of the limits and protections that Intel has turned on. So I'm not going to turn off CEP, but I do want to run a low AC load line, and so we do need to run, we do need to lower the VRM load line to match the AC/DC load line settings of the CPU. Anyway, to do that, we're going to set the light load to mode 3. So VRM load line calibration to mode 3 and light load to mode 3. And this will keep CEP happy, and this will also knock down the voltages. Because Intel's V-droop compensation is honestly kind of scary in how it works, which we will cover in a future video. I've kind of covered it in a past video, but that video is like 2 hours long, and I don't manage to show the worst case scenario. Anyway, I forgot to clear the... Wait, no, I did clear it. Yeah, so we maxed it at like 1.47. I mean, we can just restart again. Now, what I've just done is not going to do anything for the performance. It's really not, like, it's just not going to change. But our voltages are lower. Mind you, not massively lower. Like, yeah, during startup, we didn't see anything, in excess of 1.5 volts now. But once we get to running Cinebench 15, we're going to be back over 1.55 volt. Not 1.55, above 1.5 volts again. Yeah, because that's kind of the funny thing is just... Well, actually, it's not really funny. It's just my CPU is really bad. So it has, like, the vids on my CPU for basically every possible scenario are about as bad as they're going to get. Unless you have a really bad KS. Anyway, so let's run some 15. And actually, like, once we're in the OS, you can see that, yeah, we've already managed to hit up to 1.48. And now if we also mix some, like, significant current flowing through the CPU into the scenario, yeah, it just... we get somewhat higher voltages. Also, the score didn't really change. Yeah, so now we're over like 1.51 volts. And I suspect most of the reason for why that's happening is actually now we're getting, like, because I set the load line so aggressive, we're getting like kind of probably quite a bit of overshoot right now. But that is better than having the CPU request insane vids. Because, like, short spikes due to overshoot is better than, like, long spikes due to V-droop compensation. Or at least that's my thought process on that. Anyway. So... yay, and we're all the way up 1.55. It's kind of funny how it just kind of happens as you're just doing stuff in the OS. Like I mentioned earlier, Cinebench 15 is the most consistent for triggering spikes, but it isn't the only thing that triggers high voltage spikes. So yeah, we're back to 1.55 volts, but at least we got rid of that like massive voltage spike during Windows startup, so that's nice, I guess. Anyway, while R23 is running, you will notice that our average voltage is actually still the same as it was before. Or actually, no, it's a little bit lower. I guess I should pull up hardware info. And it should be a little bit lower. Though our score is basically the same. So yeah, our core voltage, while hardware info is, while Cinebench is running, is about 1.234 volts. So we shaved off about 20 millivolts, which makes sense for the adjustment we've made. Right, because previously we were at around 1.25, now we're at about 1.23. So yeah, also we managed to spike above 1.55 volts. Well, this is why I really wish we had a VR voltage limit, because then I could just set a voltage limit of like 1.5 and this wouldn't be a problem. Or 1.45 and this wouldn't be a problem. And it wouldn't even really affect the performance. Because the funny thing is, those high voltages happen when the CPU is like it happens right as it finishes a workload or right as it starts a workload. But anyway, so now let's tone the voltages down even more and also get some extra performance. So we're going to set the CPU core voltage mode to adaptive and then offset mode to negative, and then we're just going to punch in like 0. Well, I think for most, like if you don't really want to spend a bunch of time fiddling with this, probably start with like 0.07 should work like on most CPUs, but the lower you set this, the more performance you're going to get, right? So anyway, I guess we can just sort of show the full range of improvement. So we're going to start with like 0.07 negative offset. And this should basically keep us at a maximum voltage of like 1.48, 1.5-ish. Because now every vid request that the CPU will ever make gets lowered by 70 millivolts, right? And the highest vid requests that my CPU makes is like 1.4 all-core and 1.5 single-core. So those have just gotten knocked way down. And that's like, those vid requests are before the AC load line stuff happens, because nothing can ever be as simple as just being one number for all scenarios. It's like different numbers depending on the scenario. But yeah, so the score's gone up a bit. Voltages are obviously lower. Also, if we look at the average, like the actual average voltage, what you'll notice is that like we set a 70 millivolt offset in the BIOS, but we're not actually going to be 70 millivolts lower when running Cinebench, because as we apply a bigger and bigger offset, yeah, so like previously we were at like 1.234 and now we're at like 1.22. So, you know, we applied a 70 millivolt negative offset and we're only getting like a 10 millivolt voltage reduction. And the reason that happens is because as we lower the core voltage, as we lower the offsets. So as we apply a more of a negative voltage offset, the CPU just runs higher frequencies, which is why the score goes up, right? If we were already hitting the max frequency, like if this CPU somehow in some fantasy land was running 5.7 gigahertz all core, which it basically never does, because the CPU is a potato. So even with no power limit, this thing really doesn't sustain 5.7 gigahertz. Yeah, so with the Intel default settings, this CPU runs like 5.1 gigahertz usually for Cinebench. Well, now that we've offset the voltage by 70 millivolts, instead of running at 5.1 gigahertz, it runs at 5.2. And the vid actually it runs at like it runs at like 5.3. And the vid voltage for this higher frequency is higher, right? So the 5.1 gigahertz vid voltage point is lower, but is like 70 millivolts lower, but we're not using that voltage point anymore. We're using the voltage point for 5.3 gigahertz. And that's why even though we applied like a 70 millivolt offset, our voltage only went down by like 10, 20 millivolts, right? Now, if you're running lighter workloads, the voltage is actually 70 millivolts lower, right? In any scenario where the CPU wasn't power throttling, it is just actually 70 millivolts lower now, or thermal throttling. But anywhere where the CPU is throttling, lowering the offsetting the core voltage, applying a bigger negative offset, isn't actually going to directly translate into a voltage reduction. It's just going to raise the core ratio. So yeah, that's something to keep in mind. But as you can see, with the 17 millivolt offset, we're not going over 1.5 volts anymore. Which is a bit more of an improvement than I was expecting. I was still expecting it to hit like 1.48, but maybe maybe I just didn't do the correct combination of programs to get the highest possible peak voltage yet. Not that we're going to spend a bunch of time on that. So the next thing we're going to do is we're going to do now the thing with these negative offsets is you have to keep in mind how much of a negative offset you're going to be able to run is random. So if you have a really, and the funny thing is it's not even really good CPU or really bad CPU, because the vids that Intel programs into the CPUs at the factory, which set the voltage for each frequency, are not necessarily set with the same safety margin for every single CPU. So you might have a CPU that has very high stock voltages, but that's because it has a huge safety margin. And then you can have a CPU which has very low stock voltages, but undervolts like garbage because it came from the factory with very little safety margin, right? That would also that also means that if your CPU if CPUs are degrading, a CPU with a big safety margin can degrade 100 millivolts before it stops being stable, and a CPU with a small margin can degrade by 50 before it stops being stable, right? So even if they were degrading at the same rate, they would actually stop being stable at different times. So yeah, there's too many variables to this. But anyway, so that's a 70 millivolt offset. I would think basically any CPU should be able to run a 70 millivolt offset. I could be wrong about that, but I would think 70 millivolts is basically guaranteed to work. Now, 100 millivolts and higher offsets is where I think you're going to start running into situations where the CPU isn't stable anymore. Now, 100 millivolts on my CPU does still work. We're going to go a bit higher than that to just sort of try get as much out of it as possible. We're going to go all the way to 130. And so now we should be just about getting 40,000 points in Cinebench. Also, our max voltage is going to be even lower again. But at this point, with some CPUs, this kind of offset might not be stable. So anyway, we're this time I'm not going to bother with Cinebench 15 because it doesn't really, I think R23 should give us enough of a spike anyway. Because there's one last I want to show you what it looks like when it really stops being stable because your offset is way too low. Now, the thing with these negative voltage offsets is that Intel CPUs do have some built-in error correction, which means you're not necessarily going to see outright crashing. You can end up seeing weird performance issues, crashing, just weirdness. So if you're undervolting your CPU and your system starts being weird and slow and just, buggy, you might be undervolted too much. Anyway, you'll notice that we went from on the 70 millivolt offset, we were getting 1.22 volts. Well, now we're on minus 130 and we're still getting 1.2 volts, right? But the score is way higher. We're almost at 40,000 points now. Actually, I think if Hardware Info wasn't running, this would probably be over 40,000 points. But also at this point, the CPU could be unstable in certain things. Now, in my testing with Cinebench 15, this should still work. Actually, you know what? Just for just for demonstration purposes. Let's quickly run 15. I like how short 15 is. Also, you can see that, yeah, our max voltage is now actually consistently lower. So that's good news. And actually 15 crashed. It's kind of random. It doesn't, yeah, so I was not expecting that, but it did just crash. So the reason I'm saying that's kind of random is because in a previous take of this video, I actually managed to get get the system, like Cinebench 23 would still finish even with like 160 millivolt offset. And at that point 15 froze up. And in pre-testing, I actually managed to pass 15 with like 150 millivolts at one point. So actually we're going to briefly like stick 150 on there. But yeah, the thing is like just like Cinebench crashing, also like Cinebench isn't the end all be all of stability testing, right? And just because you're passing like stress test doesn't necessarily mean like, because the thing is when you're offsetting the voltage, it offsets the voltage for every single operating frequency of the CPU, right? So it's really, really hard to verify that you're stable at every operating frequency, right? It's not like, oh, this isn't like a static overclock where you just throw prime 95 at it and either it crashes or it doesn't. And, that's the end of that. Here, like, you might end up with like, oh, minus 150 is stable in Cinebench 23, but it's not stable in Cinebench 15. Or maybe it even is stable in Cinebench 15, but then you go play some game and that game isn't stable because that game has a slightly different, like frequency voltage behavior than your stress test. And so that's like the thing with the undervolts is, you know, like the more you push this down, the more likely your system is to not work correctly. You're going to be back to where we were with the undervolted out of the box motherboard BIOSes, where you could buy a brand new CPU and it wouldn't be able to run Cinebench because your motherboard was applying like 160 millivolts of negative offset at high currents. It wasn't doing it at low currents, so you still got your like massive amounts of peak voltage. So the CPU would degrade anyway. But hey, at least you had a huge Cinebench score on the 1 in 10 runs that didn't crash. So, and at this point, I think we're going to see even lower, like, max voltages. But, like, the stability, I think, is going to be atrocious. Also, what's really interesting, and I think the reason why 15 is so much harder than 23 is it actually looks quite different on the oscilloscope. So as you can see, that just ran, and that got, over 40,000 points, which is basically, like, that's about as high as it gets with this CPU, at least with, like, undervolting on the Intel default settings. Now, if we run Cinebench 15, it might crash. It might not. But yeah, you can see how, like, Cinebench 15 running, it has, like, a lot more, like, the voltage behavior is a lot more dynamic, and it just crashed. So that's probably one of the reasons why 15 is, like, so much, like, why 23 is easier to run than 15 when doing big, heavy undervolts. Because, yeah, Cinebench 15 just loads the CPU slightly differently than Cinebench 23 does. And this also means, like, yeah, you might have a, like, this is the main issue I have with recommending undervolting to people, is, like, you are offsetting the operating voltage for every single possible combination of, like, software and operating frequency on your CPU. And it is incredibly hard to test every possible scenario that your CPU is going to experience. That's why the CPU comes with such a massive safety margin from the factory, right? Because Intel and AMD and NVIDIA, they don't want to spend a month verifying that every single possible instruction in every single possible sequence of instructions is going to execute correctly when the voltage is like within, 5 millivolts of being unstable. So instead, they ship the CPU with like, this thing seems to have like 100 millivolts of margin on it easily, right? Probably more than that. So yeah, like they'll ship the chip with like 50, 100, maybe 150 millivolts of safety margin if you get really lucky, or unlucky depending on how you look at it, right? And this is why, is because they don't actually want to go and just test every possible load scenario with every possible, because yeah, it just like, because here I'm showing like, oh yeah, Cinebench 15 is upset about this undervolt, but like, for all I know, the minus 100 millivolt undervolt could have been unstable in some application that I just don't know about, that just isn't on this computer yet, and then one day you download a new app and you're like, oh man, garbage software, it's crashing, and it's actually your undervolt that's causing it to crash, because that app just uses a sequence of instructions that you never tested, which, yeah, that's like, and that's mainly a problem with like dynamic sort of clocks, because the thing is, if you're running static clocks, there's a really easy test. You can just run Prime 95 on it, and if that runs, everything runs. Okay, that's not entirely true, but you can basically, like, there's like a few different applications you can run, and they hit the CPU so hard that it doesn't matter what else you run, especially if you have a relatively droopy LLC. Like, because those applications run the CPU so hard, any other software you're ever going to run is probably going to end up running at higher operating voltages anyway because of the V-droop, so you don't have to worry about it. Yeah, if you're on a CPU which has like I mean, Intel doesn't have exactly the world's most granular boost algorithm, but there's like you have the 6 gigahertz, 5.9, 5.8, right? Like, so it goes in like 100 megahertz steps. So just between 5 gigahertz and 6 gigahertz, you have like 10 different frequency voltage combinations. And if one of those isn't stable in one application, it's going to crash, right? Or it's just going to be really weird. And so that's like the main concern with undervolting, is just like stability testing it is really, really, really frustrating. So I like, if you don't want to spend a whole bunch of time verifying that your CPU isn't going to randomly crash or just cause weird issues, just undervolt it less. Which is the main reason I really wish this motherboard had a voltage limit, because then you wouldn't need to undervolt to get the voltages under control, right? You could just set a voltage limit. But apparently that's like too much for MSI. Alternatively, if you don't want to undervolt and you do still want to like get the voltages down, you can lower the core ratio, but that straight up slows the CPU. Like that's a really like that's a really brute force approach to solving the issue. And MSI also makes that a little bit kind of annoying, because you basically want to use turbo ratio, and then you might want to say, okay, I want to make, absolutely certain that the CPU doesn't go to any insane voltages. So we set this to 8 so that it applies to all of the P cores, and then set like 56. And I'm going to turn off the offset just to show what happens if, like you're not using the offset. I mean, we could still combine it with a very mild offset, like minus 50 millivolts or something, right? Just, and this, I wouldn't be so, I wouldn't be as worried about this being unstable as like minus 100 millivolts, which very realistically could be unstable in a whole bunch of scenarios that I just don't know about. If you're really unlucky, I guess even 50 millivolts might be too much of an undervolt, in which case, yeah, you're screwed, I guess. So anyway, but the other thing that annoys me about this is MSI just set this to MSI Unlimited. So, I'm going to put it back to Intel default settings, because I am not entirely sure, and I'm honestly, I don't I wonder if the if the MSI unlimited settings mess with the load line settings again, or if they don't. Both of those are actually bad, depending on what exactly is happening. So anyway, I put it back to Intel defaults. So I wish MSI didn't do that. They do at least warn you. Like a message did pop up that, hey, we're changing over to unlimited. But yeah, as you can see, if I limit the ratio to 56, like we're already above, like we're already, yeah. So like limiting the core ratio is just a really heavy, finally remembered the phrase, heavy-handed approach to solving the issue. Because, like, yeah, you get better voltages, but also you're losing all of your single core performance. You're literally turning your i9. I mean, for Cinebench, it's actually still fine because you might have noticed when we were running Cinebench, the CPU was at like 5.3 gigahertz, right? So this isn't actually going to affect Cinebench, but for other multi-core loads that aren't as power limited as Cinebench is, we just threw out 100 megahertz. We just, we just threw them away. Admittedly, 100 megahertz isn't much of a isn't really a big deal, right? Because like 100 megahertz at 5 gigahertz is like 2%. So it's not like you're really going to notice. But, if you keep going down this path of I'm just going to lower the ratio to get lower voltages, you could have just bought an i7 instead. Which I still think would have been a better idea anyway, because the i9s are incredibly overpriced for what they are. You get 4 extra E-cores and a worse vid table. Okay, it's actually not worse, because the silicon quality is higher, but like because Intel's pushing the frequency so high out of the box, the vid tables end up really high anyway. Right, whereas like the very worst i7s are like slightly over 1.4, whereas like the average i9 is around 1.45. Anyway, so yeah, like I said, it doesn't really affect, like lowering the all-core ratio doesn't really affect Cinebench R23 unless you had a CPU that wasn't constantly power throttling, which I don't think is possible with the Intel defaults. So yeah. Anyway, so the lowering the core ratio, and also you'll notice that like the voltages aren't exactly amazing. So lowering the core ratio is like it is an option. I just don't like it as an option because it's really like you need to chop off a lot more performance to get the same kind of voltage reductions as even like a 50 millivolt undervolt, right? Or 70 millivolt undervolt. So anyway, yeah, the main thing for like getting the CPU sort of to not be kind of insane on a motherboard like this is mode 3 on the load line calibration, adaptive plus offset mode. Oh, also I should mention, don't try to run Prime 95 on this motherboard. It causes it to reset randomly. I don't know why. It just does that. I think it's tripping some kind of protection. Because the board literally just, like, reboots when running Prime 95. But anyway, so yeah. CPU light load, mode 3. You don't need to touch anything else in this menu. And that's kind of that. Just adaptive plus offset, and then play with the offset until your system is unstable, basically. Because yeah, there's really no better, like, unfortunately, I've just not found a good way to stress test dynamic frequencies. Because like I said, like, what if you need to test so many different scenarios to hit every single combination of, like, temperature and frequency and voltage and workload, and it just, yeah. But I think down to 0.1, most CPUs shouldn't have problems. And then below 0.1, things will start getting like, like I think a lot of CPUs will actually end up being unstable. So yeah. So that's that. Yeah, this motherboard is I'm conflicted about this motherboard. Because I, like, didn't... Because when I first tested this motherboard, I thought it was pretty decent. But, like, now it's like, okay, so there's no VR voltage limit, which at the time was like, well, why would you even need that? Right? That's, like, just a setting that you don't use. Or at least you didn't use it, like, you wouldn't use it in the past because there was no reason to. And then the fact that the VRM has that weird, like, voltage issue when booting up Windows is like, yeah. The thing is, I don't think I even tested this motherboard at, like, stock settings. So, in the past, like, I just don't, you know, like, I don't usually bother running stock settings on CPUs. Because the assumption is that, like, the stock settings are, you know, properly validated by somebody, which apparently with LGA 1700 was like no one. No one bothered to test anything. Well, anyway, so hopefully this is somewhat helpful if you have one of these MSI boards, and an i9 in it. And the next board I'm going to move on to is an Asus board, which should be a lot less annoying to try optimize because that actually has the voltage limit setting. So, yeah. Anyway, that's it. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts and hoodies and posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And yeah, that's it for the video. So thanks for watching and goodbye.